I bought a faulty Milwaukee Spot light off eBay. It's a M12 SLED. Bought it for spares a repair. You press the button to switch it on. You just get 4 lights flashing. And apart from that, it does not a lot. It's got a mode button on the back here. I'm not sure what that does, but again, it doesn't appear to be doing a lot. So we shall take it apart and we'll see if we can repair it. There's a small screw just in this side here, and I think the rest of them are T10s. Right, let's see what we've got in here then. I think there's supposed to be a little clip that holds the bottom together, but that appears to be missing, so let's see how this comes apart. Little mode switch there. Little trigger, we'll put that to one side. And we have the battery connector, which is just using the 2 battery terminals by the look of it. It's not using that one. We have a little toggle push button, a little press button there, and obviously a little driver board. Looks like a small microcontroller here. Possibly about 3 MOSFETs, a couple of other ICs there, and a couple of capacitors, and apart from that, maybe a little voltage regulator there, and that looks about it. So we shall hook a battery up. I might bring the microscope in on this one so we can explore the circuit board and see what's going on. So let's explore. Looks like the power comes in here, goes through this fuse, goes through a Zener diode there. Looks like we've got a MOSFET, which must get switched on by the microcontroller, I would have thought. We've got a MOSFET here and another MOSFET here. Now that's the gate of the MOSFET there, seems to go down here to this chip here, which is an MP1906. Now a quick Google search reveals that that's a MOSFET driver, and there's also another trace coming out the bottom of it, which seems to go to this MOSFET here. Now there's this MOSFET here goes to an inductor, which is just on the back of the board here. So I think this is being used as a buck converter to drop the voltage to the LED. From the MOSFET driver, it looks like the tracks run over in this direction, and it looks like one of them goes under this diode to the microcontroller. So it looks like the microcontroller is providing the oscillation to the MOSFET driver, and that in turn is driving the 2 MOSFETs here and here, which then drive the coil. We've got a diode here, and then I think it goes through this capacitor here. Which I then would think it would end up going through to the LED. Now there's another chip here which is a dual op amp, but I think they're only using one side of it because the input pins are grounded here. That's the output pin there, and the supply voltage comes in on the 2 pins here and here. The input, and I think that's the output pin on there. I'll have to double check the data sheet, but it looks like we've got 2 current sense resistors here, and then once it actually detects or measures the current going through, the output of the op amp cascades down here and ends up at the microcontroller as well. So pretty much the microcontroller is doing all the work. Here's where the LED output connects, and what have we got down here? We've got a few resistors and that and stuff. And I think that is a voltage regulator that supplies the voltage to the microcontroller. I think that's about it. So why isn't it lighting up though? That's the question. Obviously the microcontroller is doing something. I wonder if we can tag a couple of wires just onto these connections here, because I think those will be the LED output pins. Just looking at the cable on the, if I can bring that into shot there. Just looking at the cable here, the two thick ones, which are red and black, and we've got two ones on the outside there which are a little bit thinner. So I would have thought the main power for the LED are going to be the two centre ones. So I think we'll connect something up to these, and we'll see if we can see if we're getting any voltage out of it. I think that'll be the first thing that we'll try. So I've just connected just a small automotive bulb just onto the two contacts that I was just mentioned previously there. We've got the battery connected up, and it's still flashing. Now what I have noticed, when you first switch it on for a brief moment, you do get the lamp flashing there. And one of the other things I've noticed, if I switch it on quick and then press the mode button, the bulb actually lights up. It still continues to flash and then it goes off. So it does seem to be providing some kind of power to the output. I'll tell you what, let's see exactly what voltage we're getting there. This could be the diode on the booster circuit or something, possibly, or I'll just hold these probes on. Nope. I think we're getting about 12 volts there, which seems a bit high. Now, I think I might have just took the fuse out there, because I did hear some, oh no, it seems to be yeah, something doesn't look quite right there. I wonder if it's because we're using a bulb instead of an LED and it's throwing it out as well. But then again, the LED in here isn't lighting up. I wonder if we should take this apart just to check inside of here. That might be an option as well. I'll untag these wires a sec. How does this come apart? Let's see. Right, so that's the reflector out of the way, and we've got an LED module down the bottom here. It's got a really big heatsink on this, so I'm not sure what type of LED it is or what the output is, but it's got a quite substantial heatsink on it. Right, so this is the LED module. A little bit of discoloration around the board here. And we've got some thermal paste on the back. It looks like there's a small temperature sensor here as well, so if it does get too warm, it looks like that, and that's what the other two wires are here by the look of it. Now it is MT plus and MT minus. I'll just bring this a bit closer so you can see. Yeah, so it looks like there's a little temperature sensor there, and then we've got the LED here. So it looks like the black and red go straight to the LED, and the white and green go to the little temperature sensor here. Now with it one being a single LED, I would have thought that would only be about 3 volts or so. So it seems like we've got a lot of output on there. So I wonder if the LED is actually blown. And if I put it on diode and I go on these two pins here, I'm just getting an open circuit reading on this. So I wonder if the LED is actually blown. So it might be fun trying to solder an LED on there, unless you can actually buy a replacement module. So it looks like there might be 2 faults, and this looks like there might be a fault with the driver circuit and a fault with the actual LED as well. So I've replaced the LM2904 because that seems to be what measures the current and that stuff. I've checked all the resistors around there and it seems to be doing exactly the same, but I'm not sure whether it's because I was driving a bulb instead of not the LED and the current draw might be different and whatever. But anyway, so I can't actually find any problem with that circuit as such. But to change the LED, we had a bit of a problem because I can't use the hot air because it'll just melt the LED, and it's soldered underneath. So I've made this hot plate here. Now I did look at a one on YouTube that Electro Noobs had made, and it's pretty much the same, apart from I didn't have the same components as what he did. So I've used an Arduino Mega because that's what I've got. I've changed the software slightly as well because of the heat profile for the LED was different to the one that he was using and whatever. So, and I'm just using an external power supply for it instead of using the I think he made a one with an internal power supply and whatever. But anyway, it's just what I had, so this is what I used. So let's see if it actually works. So if I remember which button switch it on. Right, it appears I had the solid state relay output pin, or input pin, whichever way you look at it, was on pin 3 here instead of pin 4. It must have put it in the wrong hole. Right, we shall try this now then. There we go, I can see the light on the relay now. And it's heating up. And we're up to about 87, 89, 90 degrees now. Up to 184 degrees. I removed the wires. Well, we've removed the LED. We've also removed the wires, but we can solder those back on, so it's not a huge problem. Right, so I'm not sure what this LED actually was, but I've ordered a Cree LED, which, from what I've looked at the specifications of the torch, seems to be similar, if not the same. So I'm not 100%, but you know, so this is the LED I've got. That's the Cree part number there, XP LAWT 000V or whatever. and the RS catalogue number is 9080705. So we'll get the new LED. Out of its package. Yeah, I actually think it might be the same LED. They look very similar. Maybe a slightly different. That one looks very slightly yellower, and that one looks very slightly more orange. I'll just have a look on the back. If I can get it to sort of stand up, because there is a little notch that indicates the polarity. And I'll probably have to go and check on the data sheet just to make sure that I'm putting it around the right way. I can get this one to stand up on its end, maybe. Yeah, so they've both got the same notch there as well. So yeah, I think it might be the same LED. Right, I'll just double check which way it goes around on the board, because we'd hate to put it on the wrong way, and then I'll be back. Right, so the anode is the side marked with the little notch there. So the anode's to the positive side, so it means that LED needs to go on this way. And we'll just try and line that up a little bit. I think something about that. Right, we'll fire this up then. Right, so we'll let that cool down and we'll come back to it. I've just cleaned up a little bit here, soldered the leads back onto the new LED. And what I've noticed is when I actually measure it, I'll tell you what, I'll switch that off as well so it's not glaring there. When I put the test meter onto diode check now, I don't get a reading still, but the LED actually lights up, and it wasn't doing that with the old one. So I've got a feeling the LED had failed. Right, so I'll put this LED back into the holder, so it's heat sinked. I tell you what, I'm going to put some thermal compound on here first. I'll put some MX for this. I'm going to put a splodge of that on the back of here. I'll put this back in. I'll attempt to. And then once I've got it screwed in, we shall give it a test. Right, I'll just screw this in and we'll get this out of the way. Right, pop the screws back in there now. So we'll couple that up to there. Right, let's see what it does. Oh, we've got high and low there. Right. Looks like it might have just been a failed LED on this then. Anyway, we'll just check the voltage, or try to. We'll just check the voltage we're getting out of here now, when it's on. .65. Oh, I think I just caught the yeah, so I think that's it. Right, and we'll put the reflector on that back on. I'll tell you what, I'll just disconnect all this for now. Right, which way did this go in? I went like that. And it was these screws, wasn't it? No, it wasn't. Yes, it was. was it? Yes. Actually, no, it wasn't. It was the shorter ones. I thought that seemed a bit long. I just want to come out now. Nice. Yeah, because these ones have got some of this gunk on still, so. Yeah, I like spotlights and LED lights and things. As you can probably tell, I fixed a few Milwaukee ones now. I've actually got another big Milwaukee work light to look at, which I haven't looked at yet. That'll be another video coming up. Right, let's see how this went back in then. That's the reflector back in. Oh yeah, there was this cap to go on. That went in about there. Yeah, that must have went in that way because the switches are that side. And the LED lights go in there, don't they? So put this bit out of the way first. We'll slot that board in there first. Got this little mode switch, which is for high or low. That's in there like that. That works, yeah. Right, where did this battery connector go? It went somewhere around about there, didn't it? Is that going that way? Yes. Right, so the trigger to go in now. And the other side of the case, which is here. That was a smaller screw for that one, wasn't it? Which was that one. I don't know why they've got a smaller screw in there. It's a little bit odd, but. Right. So I've got low and high. Yeah, I quite like that. Yeah, it's a bit bright. Yeah. Right then, another job fixed. Not a bad little light, that. Well, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave them in the comment section below. And as always, have a great day. Thank you for watching.